Hopefully you remember from the last lesson that anytime we are dealing with variables instead of numbers, that means we're dealing with a right triangle, and we're going old school with SOHCAHTOA. But it's the same 3 steps. So step 1, use the inside to build your triangle. So I know tangent is SOHCAHTOA. So the opposite is x, the adjacent is 1. Step 2, use Pythagorean's theorem to finish solving your triangle. Then step 3, use the outside to get your answer. Now, this one we do need to be a little careful of because we have that 2. So on step 3, we're going to rewrite this is actually tangent of 2 theta. Basically, I made all of this, substituted that for my theta. Hopefully you will recognize this is a double angle identity. So I use my double angle identity to change tangent of 2 theta to 2 tangent of theta over 1 minus tangent squared of theta. And now I plug in what I know. So tangent of theta, tangent is x over 1 because it's opposite over adjacent. Opposite over adjacent. And 1 minus opposite over adjacent squared. So that's going to give me 2x over 1 minus x squared. That is my tangent equation. Now we do also still need to find the domain. So hopefully you remember with yesterday, we always start with the base domain of the inside. So I'm going to look at the inside function, that's arctan. And I'm going to go back to my little table that I made and look at what the domain for arctan is. So the basic arctan domain is negative infinity to infinity. Now I'm going to adjust it based on my answer. So I look over here at my answer and I notice I have a 1 minus x squared in the denominator. So I know the denominator cannot equal 0. So I'm going to solve this out. And I get a plus or minus 1. So I know that I have this domain, but I also have x cannot equal positive or negative 1. So my final domain, oops, that got too much, will be negative infinity up to negative 1. Negative 1 to 1, and 1 to infinity. So basically, negative infinity to positive infinity, I just can't include those because of the denominator. So let's try one more. Here we have this one. I would actually like you to try to start this one on your own. Here's what I mean by start it. I want you to do step 1 and step 2 on your own. So step 1, use the inside to build your triangle. And remember, cotangent is going to be tangent flipped. So instead of opposite over adjacent, this is going to be adjacent over opposite. So use that to build your triangle. And then step 2, use Pythagorean's theorem to finish your triangle. Pause the video and try to do those 2 steps on your own, and then we'll come back and finish it together. Check to see if you filled in your triangle correctly. So I have adjacent over opposite. I use Pythagorean's theorem to find that side. Now we're going to find cosine because that's our outside function. So cosine is adjacent over hypotenuse. My adjacent side is 2x. My hypotenuse side is 4x squared plus 1. And that should be my answer. Now let's look at the domain. The base domain of the inside is arc cotangent, which, if I check my table, is negative infinity to infinity. But we do have something in the denominator, so we better check and make sure about that. So we know we have an even root in the denominator. We know that whatever is inside the even root must be greater than or equal to 0. Whatever's in the even root has to be positive. However, because that root is also in the denominator, it cannot equal 0, because that would be dividing by 0. So we're just going to say whatever's in the root must be greater than 0, because that root is in the denominator. So let's try to solve this. And I'll pretty quickly notice that I'm square rooting a negative, which does not work. So that means that so far, my domain is still just negative infinity to infinity. Now, one last thing to be careful of. Hopefully you noticed this time that the 2 was in a different place in the equation. With our first example, the 2 was in front of the arctan, so we had to use a double angle. Here, the 2 was inside, so it changed what we put into our triangle. However, when the 2 is on the very most inside, that's also going to affect your domain. Here's what we have to do with it. So this is anytime we have a number on the very most inside. We need to essentially get this back to an x. We need to undo whatever's happening to get it back to an x, because x is what we normally want on the inside. So if I want to get this back to an x, I need to get rid of the 2. Well, the 2 is multiplying, so to get rid of it, I have to divide. So I'm dividing by 2 to get this back to its normal x, which means I need to divide the domain by 2 as well. Now, in this case, it doesn't make much of a difference because infinity divided by 2 is still infinity. But that will make a difference in a problem we'll do later in this lesson. So anytime you have a number on the very most inside, you have to think of undoing it, and that is what you do to the domain. So that is everything with tangent and cotangent. Come back in the next videos where we'll talk about secant and cosecant.